2 days, and today we're going to focus on inverses of matrices. And by the end of today, we'll be able to understand the significance of an identity matrix and then find inverse matrices. So we have to know what the identity is in order to find an inverse. So let's think about the role the identity plays. So the identity matrix, when we're multiplying, has the same role as 1 does. 1 is actually the multiplicative inverse, because when you multiply 1 by A, what do you get? What's 1 times A? A. If you do A times 1, what do you get? Also A, right? So that's why it's called the multiplicative inverse. Because whenever you multiply by 1, what do you get? Whatever you multiply by, right? So whatever you multiply by, that's the number that you're going to get. So a square matrix is going to be important in what we're doing today. A square matrix is one that has the same number of rows as columns. And the main diagonal of the square matrix is going to have entries whose row and column numbers are the same. And the entries stretch diagonally down the matrix from the top left to the bottom right. So we're going to officially define identity matrix. So that's the identity matrix we call I sub n, and that's the n by n matrix for which each main diagonal entry is 1, and then all other entries are 0. So the main diagonal is 1, and then all other entries are 0. So we're going to take a look at what some of those identity matrices are. Okay, so if you look at the 2 by 2, here's your diagonal of 1s, and then the rest are 0. I sub 3 is the 3 by 3, so you have the 3 1s in the diagonal, all the rest are 0. And then I sub 4, you have the 4 1s on the diagonal, all the rest are 0. These look really familiar because they're in what form? What form has zeros above and below the 1? Reduced row echelon form. Okay, that's exactly right. Remember earlier I told you that you wanted to practice putting a couple in reduced row, because that's what we're going to do later on. Today is that later on. Okay, so identity matrices are going to behave like the number 1, because when you multiply a matrix by its identity, you should end up with that same matrix. Now, yesterday, remember how we talked about how multiplication isn't commutative? When you multiply by the identity, if you multiplied by the identity by the matrix, you would still get that matrix. Okay, so when you multiply by the identity, it doesn't matter if you multiply by the identity second or by the identity first. It is going to be that same matrix. Okay, so for example 1, we're going to multiply the following matrices by their appropriate identity matrix, and those are already given to you. So using what we did yesterday, we're going to practice multiplying. Okay, so do you guys think you can multiply for part A? Okay, so first we'll make sure that they're compatible, right? So I have a 2 by 2 matrix and a 2 by 3 matrix, so can I multiply those together? Yeah. And then my result would be what kind of matrix? 2 by 3. Alright, so then for the first row, the first column, I'm multiplying the first row by this column. When I do 1 times 3, I get 3. And this is going to end up being plus 0. So I have 3 on the top. Now look at this pattern that starts happening. Every time I multiply the second term, I'm going to get what? 0. So if you have 1 times 5, you'll just have 5. The second one will be plus 0. The third one, 1 times 6 would be 6. 6 plus 0. So on the top I have 3, 5, 6. When I go to the second row, see how I have 0 here? So when I multiply by the first one, I always get 0 first. And then 1 times negative 1 is negative 1. So that's what my result is going to be. So the first one is always 0. And then you're just doing 1 times the second, which is giving you 2. And then for the third one, you'll have 0 plus 7, which will be 7. Right? So does this look familiar? Yes, it's this matrix here, which is what we just said, right? When you multiply by the identity, you should get the same matrix. Okay, so now for B, I have a 3 by 3 and a 3 by 3, which means the result is a 3 by 3. So 3 by 3, 3 by 3. Right, so now when you're multiplying the first row by the first column, look at the last 2 terms in the first column. What are those going to produce every time? 0. So really all I have to do is negative 1 times 1, and that's going to get me negative 1. When I multiply by the second column, I'm going to get a 0 for the first term and the last term. So all I have to do is multiply the middle term by 1, which will give me 7. Because it would be 0 plus 7 plus 0. And then for the last one, I only have to multiply what terms together?
1 and 1/2.
Yeah, the 1 and the 1/2. And both of those are the third term, so you'll get 1/2. Okay, and then for the second row, it's very similar. So 12 times 1 is going to give me 12, and then I'd have 0 and 0. For the second row, I'd have 0, 1 times 1, which is 1, and 0. And then for the last column, I'd have 0, 0, and then 3 times 1, which is 3. Okay, and then for this, I have negative 2 times 1, which is negative 2, plus 0 plus 0. And then here, I'd have 0 plus 0 times 1 is 0. And then for the last one, I'd have 0 plus 0, 7 times 1, which is 7. Okay, so it does not matter what order you multiply them in. Whenever you multiply by the identity, you will get that same matrix. Okay, so from the previous example, we can conclude that when we multiply a matrix by its identity, we get the same matrix. Similarly, when we multiply a number by 1, we get the same number. Alright, so that's just one of the reasons why the identity is cool. Now that we know about the identity matrix, now we can learn about the inverse of a matrix. Okay, and the inverse of a matrix is going to be the main thing we're going to focus on today, and it will also be something we're going to use tomorrow. Okay, so the inverse of a matrix. We're going to let A be a square n by n matrix. If there exists an n by n matrix which which is what we call A inverse. So it has the same notation as the inverse had when we were doing functions, inverse functions. Remember we had the f with the -1? And this is going to be with the property that A times the A inverse is going to be equal to the inverse times the matrix A, and both of those would result in the identity matrix. Okay, if that happens, then we say that this matrix is the inverse of A. Okay, so we're going to let A be a square n by n matrix. If there exists an n by n matrix, A inverse with the property that when you multiply them together, you get the identity matrix, then we say that A inverse is the inverse of A. So I said, let's explain what this equation means in words. Okay, so what's happening here between these two matrices? What are we doing to them? What does this mean? I can sit here all day if you guys can't tell me what this means. Thank you. Okay, you're multiplying the matrices together, right? So you're multiplying the matrix A by its inverse, and then what's your result going to be? What does this mean? The identity. Okay, so when we multiply a matrix by its inverse, the result is the identity matrix. Okay, so when you multiply a matrix by its inverse, the result is going to be the identity matrix. So for our next example, when we want to verify that B is the inverse of A, and we're given the two matrices A and B, we have to show two things. So we have to show that A times B is going to be equal to B times A, and that has to be equal to the identity matrix. So then let's go ahead and multiply A times B. Okay, so I have matrix A, and then I'm going to multiply that by matrix B, 3, -4, -2, 3. How did multiplying matrices go yesterday? It was so much fun. You couldn't remember the last time you had such a good time? Okay, so we're going to do the row by the column. Okay, so we're going to multiply 3 times 3, which is 9. And then plus 2 times -4, which is -8. That's going to give you 1. I'm just going to put this equals. Okay, and then for the first row, the second column, 3 times -2 is -6. 2 times 3 is 6. And now I can go to the second row, first column. So 4 times 3 is 12. 3 times -4 is -12. And then I have 4 times -2, which is -8, plus 3 times 3, which is 9. That will give me 1. So the first row, first column is 1. First row, second column is 0. Second row, first column is 0. Second row, second column is 1. Okay, so we've done half of it. Now that we've found that AB equals the identity, we have to make sure that B times A equals the identity. So let's go ahead and do B times A. And why do we have to make sure that we do both? Why do we have to do A times B and B times A? Yes, because multiplication is not commutative. Okay, so they're not necessarily going to be equal. But in this special case, they should be. Okay, and this is a 2 by 2 and a 2 by 2, so the result is a 2 by 2. So first row, first column. So 3 times 3 is 9. Negative 2 times 4 is 8. That will give you 1. And then first row, second column, 3 times 2 is 6. Negative 2 times 3 is negative 6. Second row, first column, negative 4 times 3 is negative 12. 3 times 4 is 12. And second row, second column, negative 4 times 2 is negative 8. 3 times 3 is 9. So then again, I get 1, 0, 0, 1. Okay, so since we verified that A times B equals B times A equals I squared, we just showed that those were inverse matrices. So we're just going to say yes. A times B equals B times A, which is equal to 1, 0, 0, 1. Okay, which is also known as I sub 2. Alright, so now we're going to get down to the business of finding matrices, okay, or finding inverse matrices. Okay, so the first thing we're going to do is find the inverse of a 2 by 2 matrix. Now, there's a couple different ways that you can do this. The quickest way is using the formula. So we're going to show you the formula, which will give you a simple way for finding this inverse. And you can use this on your test, but only if you know what it is. If not, then you'll have to do the other way. Okay, so we're going to write this out together. So if you have a matrix A, which has the entries A, B, C, D, and you have to put them in this order, okay? Then, so if you're given a 2 by 2 matrix, then the inverse can be found using this equation. So it's 1 over AD minus BC, and then you're going to multiply that by the matrix D, opposite of B, opposite of C, A. Okay, and then if AD minus BC equals 0, then, so first let's think about what that means. If AD minus BC equals 0, this is AD minus BC. So if this was 0, what would happen? It'd be undefined, right? So you can't have 0 in the denominator. So if you do have 0, then that means A has no inverse. And then let's talk about how this is formed. So like AD minus BC. If you look at your original matrix, can you see that AD is going to be these two multiplied together minus BC, which is these two multiplied together? So AD minus BC kind of makes like a little X there. And then let's look at the matrix. What happened with D and A's positions? They just switched. What happened with B and C?
They switch sides.
Yeah, they just switched signs, right? They became the opposite. Okay, so A and D are going to switch, B and C are going to be the opposite. Okay? Now, this quantity of AD minus BC has a special name. Okay, it is called the determinant of the matrix. Okay, if you end up going, if you end up taking linear algebra in college, you'll learn more about the determinant of a matrix and the different things that it can tell you. One thing we already know is if your determinant is 0, then there is no inverse matrix. So if the determinant is 0, then the matrix does not have an inverse. And that's because we can't divide by 0. Okay, which is what we'd have to do with the determinant. Alright, so for example 3, if you're given this is your matrix A and you want to find a inverse, let's do that using our new equation. So the inverse would be 1 over AD minus BC. Okay, so A times D would be 6 times 3 minus B times C, which would be 4 times 4. And then remember, A and D switch. So 3 becomes A, 6 is now D, those flip-flop places. And then B and C just become their opposite. So now we're going to go ahead and simplify. So what's 6 times 3? 18. 4 times 4? 16. So this would be 1 over what? 1 over 2. Okay, and then this is going to stay the same. 3, negative 4, negative 4, 6. Now, yesterday we learned how to multiply by a scalar, right? So all we have to do is distribute the 1/2 to each one of these entries. So if it's not a whole number, you're going to leave it as a fraction. So 3 times 1/2 is going to be 3 over 2. 1/2 times negative 4 is going to be negative 2. Here you're going to have negative 2, and then here you will have 3. And this is going to be the inverse of A. Now, if you wanted to make sure that was the inverse of A, what's something you could do to verify that? Okay, you can multiply by A, and what should happen if you multiply A by its inverse? You should get the identity matrix, right? So you should get 1, 0, 0, 1, right? Okay, so you could always multiply and verify that that's going to be your inverse. All right, now we're going to go to the main show here, okay? So finding the inverse of an n by n matrix. So if you have a 3 by 3 or something larger than a 3 by 3 matrix, then we're going to talk about the technique that's going to give you the most efficient way to calculate their inverses. And that's obviously without using a calculator. So if you have A is an n by n matrix, the first thing that you do is construct the n by 2n matrix. So really what's happening is you're doubling the size of that. You're going to end up doing that naturally based on the next step. Okay, so you're going to calculate that matrix that's going to have the entries of A on the left. And then it's going to be the identity matrix, I sub n, on the right. So I said observe the form below. So if you look at the form below, on this side would be matrix A. On this side is going to be your identity matrix. And this is just one that we have in general. That's why you have all the different dots there. So then what we're going to do is use the elementary row operations on this new large matrix, and that's going to change the left side into the identity matrix. And what that means is we are going to change the large matrix to reduced row echelon form. When we do this, the right side is automatically transformed into the inverse of matrix A. So remember in 10.3 I told you that you should put some of your matrices in reduced row echelon form and not just row echelon form and use back substitution because we were going to use it later. Later is now today. Okay, so we are going to be doing reduced row echelon form. So let's just talk about again and recap what this is going to look like. So the first thing you're going to do when you start your matrix is you're going to put matrix A with the identity matrix. Now usually they show this dashed line here to show that those are two of them coming together, but we're going to get rid of that dashed line because we're treating it as one large matrix. And then our goal, which we're going to achieve through utilizing our elementary row operations, is going to be to have the identity matrix now on the left side. And then what you'll have here is the inverse of matrix A. Okay, and the identity matrix is in reduced row echelon form. All right, are you guys ready to start? So my goal is that we'll get through example 4 together, and then you can practice one in class before you leave. Okay, so for example 4, you're given the matrix A. You have to find the A inverse. So the first thing we're going to do is create the matrix. That has matrix A on the left side, so 3, 1, 2, negative 8, negative 1, 1, 1, 0, 1. And then we're going to put the identity matrix right next to it. So see how this is a 3 by 3? So your identity matrix for a 3 by 3 is 1, 0, 0, 0, 1, 0, 0, 0, 1. And we put that all together. Okay, we treat this as one large matrix. So this part came from matrix A, and then this part is your I sub 3. So we're going to follow the same steps that we would to put this in reduced row echelon form. So when we do that, the first goal is to get what? What's our first goal when we're trying to get row echelon form or reduced row echelon form? Okay, yeah, get a 1 in the upper left-hand quarter. So we want this to be a 1. There's a couple different ways we can do that. What do you guys want to do? What do you want to crisscross? Well, I know. Let's find it. What's a way I could get a 1 there?
Multiply times 1/3.
Okay, so I can multiply by 1/3.
Switch 2 and 1.
I could also switch row 2 and 1. Which one do you guys want to do? Why would switching be a little easier at this point? When you multiply by 1/3, what's going to happen? You're going to get fractions. Now we won't be able to avoid fractions with this one. because I wanted to go over a tougher one with you. And this is one where you want to just make sure that you are keeping your columns organized, or else when you go to multiply by things, it can get a little bit confusing. Okay, awesome. So now that we have the 1 here, the next thing we have to do is what? What do we do next? Yep, we got to get zeros below it. Now, because we want to make both of these zeros, we can do this in the same step. And the benefit to that is going to be I'm not going to have to write out this matrix another time. Okay, so let's think about what we want to do. So you always want to multiply that top row by the opposite. So the opposite of 3 is what? -3, right? So we're going to do -3 times row 1. We're going to add that to row 2, and we're going to make that our new row 2. Okay, and then after we do that, we could also multiply row 1 by -2, and then add it to row 3, and replace row 3. So then I can kind of do 2 of them in one step. So since we aren't replacing row 1 at all, I'm just going to write row 1. So 1, -1, 0, 0, 1, 0. And then I'm going to multiply. So -3 times 1 plus 3 is going to be what? I need you guys to be with me. So when you multiply by -3 and add 3, what are you going to get? 0. Okay, when you multiply by -3, you'll get 3. 3 plus -8 is? -5. This is nice because you'll have 0. 0 plus 1. 0 plus 1. -3 plus 0. And then 0 plus 0. Okay, and now I'm going to do the last row. Okay, so I'm going to multiply -2 times 1, add it to 2 to get 0. 2 plus 1 is going to be 3. 0 plus 1 is 1. 0 plus 0 is 0. -2 plus 0 is -2. 0 plus 1 is 1. Okay, so that should be the process that you're going through. Okay, so really, you just got to make sure that you concentrate as you're doing these, because it's going to be a small mistake that would mess you up. Okay, now after I get 1, 0, 0, what's the next thing I want to get? Yep, a 1 in the second row, second column. So I want this to be a 1. Okay, and how am I going to get that to be a 1? Yep, I'm going to have to multiply by the reciprocal. So -1/5 times row 2. Okay, and I am going to have fractions, and I can't avoid that. Okay, so the first row is the same. 1, -1, 0, 0, 1, 0. The last row is the same. 0, 3, 1, 0, -2, 1. And then I'm going to multiply by -1/5, which will give me 0, 1. 1/5 times 1 is -1/5. So -1/5 again. -3 times -1/5 is what? -3 or +3/5, right? And negative times a negative will be a positive, and then you'll have 0. Okay, so then after I get the 1 here, my next goal is to get what? Yes. Okay, so I want zeros above and below. So I can multiply by the opposite, but look, see how these are already opposites? So I can just do row 2 plus row 1, and that will be my row 1. And then I want to multiply row 2 by the opposite of row 3 and add it to row 3. So if I made this negative 3 and added it to 3, I'd get 0, and that's what I want. Notice how I'm always multiplying by whatever I got is my leading 1. Okay, so what's the row I'm not changing? Row 2, so I'm going to put that in first. So 0, 1, negative 1/5, negative 1/5. I'll make this a little bigger. 3/5, 0. Okay, so go ahead and get your row 1 and your row 3.
She'll probably make a difference for every class. She's reading directly from the sheet, basically. I literally maybe got one of them on my own, and the others
Okay, so how did this one go?
I just cussed out after.
Okay, so hopefully the first one went pretty well, right? Because you're just adding these together, so 0 plus 1. And then when you're adding the fractions, you can see that we have a little bit more. Now, when you're doing 1 plus 3/5, you should know right away that this is 5/5, right? 5/5 plus 3/5 is 8/5, okay? And then 0 plus 0. For negative 3 times row 2, you're doing 0 plus 0, and then negative 3 plus 0. So then when you get into the fractions, right, you still have 3/5 plus 1, which is 8/5 again. 3/5 plus 0 is just 3/5. And then when you're multiplying here, you'll get negative 9 over 5 because you just multiply by the top. And then if you're subtracting 2, don't be afraid to write that out so you can see what your common denominator is. Okay, so this is negative 9 minus 10/5, which is going to be negative 19/5. How did that go? Okay. Okay, so that's what you guys got?
Yep.
All right, so now I have 1, 0, 0, 0, 1, 0. What do I want to get next?
One.
Yeah, a leading 1 in the third row. So to do that, what do I have to do? Multiply by the reciprocal, which is 5/8. I'm going to multiply that by row 3, which means my top 2 rows are going to stay the same. So I have 1, 0, negative 1/5, negative 1/5, 8/5, 0, 0, 1, negative 1/5, negative 1/5, 3/5, 0. And now when I multiply, I have 0, 0, 1, and then 5/8 times 3/5. What happens with the 5s when I multiply 3/5 times 5/8? They cancel, so I'm just left with what? 3 over 8. What's happening to the 5s? They're canceling out. If you guys need to, write it out, right? Those are going to cancel. Same thing here. The 5s are going to cancel, so what am I left with on the top? Negative 19. What am I left with on the bottom? 8. Okay, and then 1 times anything will be itself, so that will be 5/8. Okay, so then once you get the 1, now you want to get the zeros above it. And remember, this is one that you can do in one step. So you always want to multiply this by the opposite. So the opposite of negative 1/5 is, the opposite of negative 1/5 is 1/5. So we're going to do 1/5 times row 3. And then we're going to add it to row 1 and make it row 1. And then we're going to do the same thing, except we're going to add it to row 2 and then make it row 2. So if you're trying to get zeros, you can do those both in one step. So the only row I'm not changing is row 3. So I have 0, 0, 1, 3/8, negative 19/8, and 5/8. Okay, do you want me to do the first row with you and then let you do the second row by yourself? How did the fractions go last time? So if you're multiplying 1/5 by row 3, 1/5 times 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. 1/5 plus negative 1/5 is 0. Okay, so now I'm doing 1/5 times 3 over 8. What's 1/5 times 3 over 8? 3/40. So that might be something I want to write down. 3/40 plus row 1. So plus row 1 would be minus 1/5. So what do I need to get? Okay, and my common denominator is 40, right? So this would be 40. Okay, so it's 3 minus 8 over 40, which is going to be negative 5 over 40. What does that reduce to? Negative 1/8. Okay, so this is going to be negative 1/8. Okay, when I do 1/5 multiplied by negative 19 over 8, I'm going to get negative 19 over 40, because I just have to multiply the two bottom numbers. And then I'm going to add that to row 1, which is 8/5. So again, I have to multiply Is this what you guys got? Yeah. so then if you do 64 minus 19, we'll do 64 minus 20, which is what? 44. So then if we add 1, it'd be 45. 45 over 40 is going to reduce to? Yep, so divide by 5, divide by 5, and then you'll get 9/8. Okay, and then for the last one, you'll have 1/5 times 5/8, which is going to be 5/40ths. Okay, and then when you get 5/40ths and you add 0, you're really just going to reduce this, so it will be 1/8. Okay, and then our next one, we're going to do 1/5 times row 3, and then we're going to make that row 2. So 0 plus 0 is going to be 0, 0 plus 1 is going to be 1, 1/5 plus negative 1/5 is going to be 0. So now 1/5 times 3/8 again is going to be 3/40ths. And then look, I'm subtracting 1/5 again. Isn't that exactly what I did here? 3/40ths minus 1/5. So the result is going to be negative 1/8. Okay, and then I'm going to do 1/5 times negative 19 over 8, which again is negative 19 over 40. And then we're going to add 3/5 to that. So I'm going to get a common denominator. This is 24 over 40. Negative 19 plus 24 is what? 5. So 5 over 40 is 1 over 8. Okay, and then for the last one, I have 1/5 times 5/8, which is 1/5 times 5/8 is what? It's just 1/8, and then if I add row 2 is 0, so I'm just going to have 1/8. And then we did it. So you know that you're done when you have the identity matrix, which is reduced row echelon form. And then this side is your inverse. Bless you. Okay, so your inverse matrix is negative 1/8, 9/8, 1/8, negative 1/8, 1/8, 1/8, 3/8, negative 19/8, and 5/8. Now I want you to recognize if you do end up with a row of zeros on the bottom left of the matrix, then there's going to be no inverse. So if you end up with all zeros on the bottom, that's okay. You would just know that there's no inverse. Okay, and then if you're working on this and you want to check your answer, now you aren't going to be able to have this. You're going to have one of these without a calculator on your test, but I do want to show you how you could check it with your matrix. So you would go to matrix, go to edit. So this is a 3 by 3 matrix. So I'm going to make mine 3, negative 8, 1, 1, negative 1, 0, 2, 1, 1. And then you just go to quit, go back to your matrix, and then you're going to select A. And then see this X to the negative 1 button? That's your inverse. Enter. And then this gives it to you as a decimal, but 1 divided by 8 is 0.125. Okay, and then you could check the rest of them too, like 3 divided by 8 is 0.375. Okay, and then you would know that you did it correctly. All right, I'm going to show you our schedule and let you know what you can do tonight. tonight, I'm gonna give you a set of suggested problems and show you them from the calendar. And tomorrow, we're gonna finish 5-3, or sorry, 10-5. And then, on Thursday, I'm gonna give you some time to work on your 10-5 homework, okay? So the homework that I'm gonna show you, you can do a portion of that, and then you can do a portion in class on Thursday. Okay, and then I'll check that on